Did not record. So while you're copying this down, let me repeat myself because I forgot to press the record button. This question in its own, we have a 2x with an x. They can't be joined in any proper or useful shape or form, at least in our level. So we got to do something about it. If you remember our double angle formula, or rather the identity, cos 2x, we can rewrite it as 1 minus 2 sine squared x. And that is super valuable or super useful because our previous term is a sine. Now we have a sine, we have a sine squared. And if you have sine and sine squared, if you take a look at example 5, you know that that can be simplified further. When I substitute it in, it turns into this. And I expanded it and brought everything to the left side, leaving the right side equal to a 0. Now again, if you don't like how this looks, I am going to sub in a every time I see sine x. It gives me negative 6a squared plus 3a plus 1 equals a 0. And you know, for the sake of simplifying, I could factor out a negative 1, or I could just divide both sides by negative 1 because the right side equals a 0. But I would prefer if the first term of my trinomial is not a negative. So I'm just going to do that. Where do we go from here? What did we do in the previous question? Well, we factored. Here, we can't factor. Yeah. So it all comes back, right? That quadratic formula is so useful. So I'm going to write a little thing here saying cannot factor. Okay. And so I'm going to figure out what a is. My b, negative b is negative 3. So plus 3 plus minus. Let's see. B squared. 4 times a times c, 2a. So that is going to be 3 plus minus root 33 over 12. So I'm going to go ahead. If I can calculate what the a value is, well, then I can figure out what the sine x is equal to as well. A is going to be, based on my calculations, negative 0.229 or positive 0.729. So we're going to have two cases. So I'm going to have a case where if sine x happens to be negative 0.22. Oh, I forgot to add, if that's the case, if this is a, therefore sine x equals 0.229 or 0.729. In my head, I just assumed, but let's write it all out. So if sine equals negative 0.229, well, because it's a negative, I automatically know it's in quadrant 3 and quadrant 4. It tells me another piece of information. It tells me that if this was positive 0.229, I can find my acute related angle, right? So hypothetically speaking, how do I write this so that you don't... How about do this? So this was number 1, quadrant 2 and 3. This is number 2. What is my acute related angle? Well, if sine x happened to be a positive 0.229, in other words, if it was quadrant 1, x would be what is that? 0.231 radians. Okay, so in this case, my acute related angle is going to be 0.231 radians.
No, how do you find it in radians if you use reverse sine?
It's the same thing. It's x is equal to inverse sine of 0.229. But
you get that in radians.
you'll get a decimal. As long as your calculator is set to radians, it will give you the angle in radians. Of course.
Do we set it to radians for this whole room?
Well, everything is going to be given to you in terms of radians. So I would prefer, instead of angles, that you give it to me in radians as well.
But I also get it if it's in degrees.
This is true. You could. Then you need to convert this to negative 360 all the way to 180. You get what I mean?
Actually, when I convert it to radians, I get 13.23. And then in degrees, I get 0.2.
But let me do it.
0.
No, I get 0.231.
For radians?
Yeah.
Yes. Check that one more time.
Yeah, 13.2.
That should be degrees. 13.23 degrees. Or something like
It
that.
says like radians there, and then when I switch it to degrees.
Maybe it's because of the phone thing. Maybe what's I don't know. All I know it should be 0.231 radians. I'm not sure how the phone calculators work. Okay, so for this, for the negative, what do we have?
Just a quick question about the radian thing. How do I know if I want to switch my calculator?
Just do everything to radian. Just set it to radians. If you don't want to, then you got to figure out, like, that's a given in radians, so change it all to degrees and go for it. Right? Remember, everyone? That angle is 0.231 radians. If I'm going in the opposite direction, how will I get the same triangle in quadrant 3? In other words, how do I represent that triangle going in this direction? Pi minus, yep. And if you do so, you will get that portion. Okay. So the entire half circle is pi in the negative direction. And if I add my related angle, I will get the angle I am looking for in quadrant 3. And this gets you approximately negative 2.911 radians. In the same way, for quadrant 4, this is my 0.231 radians. That's my related angle. If I want that same triangle in quadrant 4, going in the negative direction, what would that angle be? It's just a related angle in the negative direction. So this is equal to negative 0.231 radians. Do I have to worry about the interval from 0 to pi based on the question's domain? The answer is no. From 0 to pi, I don't reach quadrant 3 or 4, so no work needed. I'm done that side. The final bit for this question is if sine happened to equal the other value from your quadratic formula. What if sine x equals positive 729? Again, number 1, what quadrant is it in? It is in quadrant 1 and 2 because it's positive. Or 2. What is the related angle? Well, if sine of the related angle happened to give me a positive 0.729, my related angle would be 817. Thank you. That's great. And so that is going to be somewhere, something like that, 0.817. I need to know what this angle would be for quadrant 1, for quadrant 2, for 2 different intervals. What is the interval? Let's do the first one, 0 to pi. In quadrant 1, the angle is just 0.817. That doesn't change. For quadrant 2, the angle is pi minus the related, which is equal to 2.325 radians. So again, pi minus 0.729, or sorry, 0.817. I'm just writing all of this to get you to copy. I know just from the look on all your faces that you're probably it's overwhelmed and you're just copying this down. And that sort of makes sense. I am rushing a bit too. Example 6 would be one of the harder questions that you would have to be faced with. And so I'm going to ask you to write this down first. But as practice, you might want to try some of the textbook questions instead. Yes?
Is that negative 3.947?
Yes, yes, yes. 957, 959. In terms of homework, don't worry about this handout with all the numbers. I'm actually going to give you a different one. I think this one is better. There is homework questions from the textbook, obviously. On this sheet, there's an equation with answers, right? No showing your work, just the answers. There's not as many questions as I think I assigned here, but hold on to it. I forgot to roll punch, so at some point in time, you can do that. That's great. Take this with you, and we're going to take a 15-minute break. Everyone could use a little bit of rest, I suppose. What I can throw at you right now is pretty intense, especially after a test. And you're probably looking forward to your weekend. So hold on. Okay. So I'm going to go ahead during that 15 to try to write out an answer key for you, like with the work shown. During that time, you guys can maybe rest or try some of these yourself.